Hello, my name is Graham, and this is our center stage robot. Our two-stage actuating intake is a key feature of our robot. The two stages of surgical tubing rollers allow us to have precise control over pixels, especially from the stack. We came out of our first competition with only the first static stage, and we decided to add the second stage so that we could gain further control over the pixels and also allow us to pick up pixels into the corners. Our intake still isn't as precise and consistent as we'd like. Although the amount of 3D printed components that we have in our intake has allowed us an extreme versatility and a really modular and upgradable system, for Worlds, we're upgrading two main features of the intake. First, we're changing our ramp into a counter roller. This allows us to remove the inconsistent and floppy ramp that we have used up till now to get the pixels off the ground and replace it with a counter roller, which will be more consistent and more precise. Secondly, we're changing all of our surgical tubing rollers over to TPU ones. This will give us more control and more reliability over the long term because we'll be able to dial these into exactly what we need using the print settings, and then we'll be able to produce multiple of them and they won't wear down like we found our surgical tubing ones do. After the intake gains control over the pixels are then grabbed by the gripper. The gripper is a really innovative part of our robot for one key reason. The over-centered linkages that allow the pixels to be maintained without any power from the servos and without putting any pressure on the servos while they're being grabbed. Over the past 2 seasons, we've broken over a dozen servos as a result of overdriving them and poor treatment in elements like grippers. Grippers are most often points of failure for servos for us because the game elements need to have a consistent force applied against them. One way that you can work around this is by using over-center linkages, which takes the full load off of the servo when it's in the fully gripped position. The gripper was one of the elements of the robot that I enjoyed designing the most, and I'm working on another design right now for Worlds, which will grab the pixel from the inside with 2 faces instead of just one. The 360 degrees of roll that our wrist provides allows precise control over mosaics when we're delivering to the backdrop. We're able to deliver those mosaics at any height on the backdrop, enabled by our cascading lift. The arm is another piece of the robot which I designed and worked with extensively, and it is 2 1/8-inch steel plates. Another integration between the hardware and the software that I've enabled is the use of the LEDs to signal the robot's state to the drivers. Our integration of machined and 3D printed parts give us precise control over where these subsystems are in relation to the robot in the field. Another innovative part of our robot is the ratcheting winch. This winch allows us to pull the robot up and not let it back down. The 1/4-inch aluminum machined plate that all of our subsystems are mounted onto. It serves as the interface between our drivetrain and the rest of our robot, and the 8mm hole pattern, which matches with our off-the-shelf Go Build It parts, allows us to mount anything in a versatile manner. For all 3 of our qualifiers, we went with an inconsistent and poorly designed drone launcher using all commercial off-the-shelf parts. Although I did the design of the launcher, I was busy with programming and rewriting our auto, so I relied on my teammates to help with the testing and tuning of the launcher. The collaboration of my teammates and I was something that was essential for our success because I could not have done all of the work myself and they couldn't have done the design by themselves. With my senior design eye and their testing and tuning time, we were able to make the most consistent launcher in the field at our championship competition. Although I had my hand in design of most of the components on the robot, from the gripper to the lift to the arm to the drone launcher, it is not possible for me to do that all alone. I needed the help of my teammates to complete all of these tasks because I also had other commitments in programming and outreach. One of the things I found most helpful when designing components of the robot is feedback from my teammates. We'll often draw out designs on paper or the whiteboard and walk through what we think is needed to make that design feasible and to actually bring it to life through 3D printed, machined, or other components. Over the past 2 years, since I introduced 3D printed and machined parts to the team, I've learned a ton about designing robots and designing other things in general. I'm really excited to continue my design journey at WPI, and thank you for considering my application. Have a great day.